Hello and welcome to Unit 3. So Unit 3 is all about the periodic trends and periodic families. So the first thing on here is the whole idea of the periodic table. We can kind of trace that back and give credit for our periodic table to a scientist named Dmitri Mendeleev. He is known as the father of the periodic table. He worked on this in the 1800s. And he was not the first person to try to organize elements into a periodic table. So he's not the first person who did this, but he's the one who started to arrange it in a way that we continue to use now. So he arranged elements by their chemical properties. Chemical properties means how they react. So is this element reactive or unreactive with water? Is it reactive or unreactive with oxygen? Does it burn? Things like that. He also arranged them by physical properties, which is what the objects look like. Is it a solid or a liquid? Is it silver or white? Is it a soft solid or is it something that's really hard? So he looked at some of those properties. Other scientists had done that as well. What was really different and important about his work is that he made predictions about the existence and the properties of undiscovered elements. So picture this. It's almost like he took the different known elements at the time, he wrote information about them on Post-its, and then he started moving them around to try to group them, and he basically said, there's something missing. There's something that belongs right here, but I don't have a Post-it for it. And so he left a space in the periodic table for those elements. And he didn't just leave it empty. He said, based on the patterns I'm seeing, this undiscovered element will look like this. It will behave like this. And later, scientists, as they started to find some of these elements, they actually found that his predictions were really accurate. And that was what made his periodic table so special and so much different than other arrangements of the elements at the time. Okay, so the periodic table is an organization of elements into groups that have similar properties. All right, on the periodic table, we have what are called vertical columns and horizontal rows. So vertical columns mean up and down. And these up and down sections of the periodic table, so if I look at a group of elements that are stacked on top of each other, for example, this group over here, when we look at that, that is called either a family or a group. So we use both of those terms to describe an up and down column on the periodic table. Within a family or a group, elements are going to have similar properties. The way that I remember that this is called a family is I think about how height is an up and down, a vertical trait, and height can run in families. Sometimes you have a family where everybody's tall, or you have a family where everybody's short. It's not true all the time, but that family is that up and down piece. The horizontal rows, horizontal means left to right. So for example, row number 2 is lithium, beryllium, boron, carbon going left to right. So horizontal means looking at a chunk of the periodic table that's going this way. This is called a period. And as we go across a period, the properties change periodically, meaning with a pattern. That's why it's called period. The way that I remember that the left to right one is called a period is if I'm reading a sentence, I read it from left to right, and then it ends with the period. I don't read a sentence from top to bottom. So families or groups and periods are how we describe the different chunks on the periodic table. We actually number the groups and the periods, and we can use that to basically play Battleship to find some of these elements on the periodic table if we know their group and period number. On the periodic table, we already have the periods numbered. So this is period or row number 1, this is period or row number 2. So these right here are the period numbers. And we have those written on here. It's 1 through 7. Make my line quite long enough. So we have 7 periods on the periodic table. Our group numbers are also numbered on here. They're just kind of buried. Instead of being at the very, very top, they're right here. So 1, 2, 3, 4, all the way across until we get to the end. That's group 18. So this right here is our group numbers that are on here. So 1 through 18 for our group numbers. So if I wanted to use this to essentially find some elements, I could start with platinum. So platinum is PT. It is over here somewhere. So we start by finding our element, and then we want to find those two numbers. So if I move over here to this side, we are in period number 6 for platinum. So I'm going to go ahead and fill that in. Platinum is in period 6. And then the group that it's in, if I trace it up to the top, that's group 10. This one, we're given the two numbers and we're trying to figure out what element it is. So group 11, period 5. So group 11, we're looking in this row. And period number 5, row number 5, we're looking here. And we're looking for where those two overlap, which would be right here. So if I move my pens, that is Ag, which is silver. All right, two more on here. So zirconium, we're going to find it right here. So our group number is 4, and our period number is 5. So group 4, period 5. Group 4, period 5. Next, we're looking for group 17 and period 3. So group 17 is here, and period 3 is right here. I'm going to find where those two overlap, which would be right here, which is chlorine. All right, so that's one thing we can see when we look at the periodic table, those group and period numbers. The periodic table is also divided into 3 big chunks, which are called metals, nonmetals, or metalloids. And this helps us identify some properties about big chunks of the periodic table at a time. Within one single family, there's more specific properties that relate to just those elements, but we're just going to first loosely break the element into 3 chunks. All right, so on our periodic table, I'm just going to do kind of a rough sketch of the periodic table. Should put helium on there. Add hydrogen. All right, so here's my rough little sketch of the periodic table. Most elements on the periodic table are metals. I'm just going to kind of chunk this out a little bit here. And what we actually see on our periodic table is there's this one section right here that has this dark line that's a stair step that goes down, starting right around boron and then going down along the periodic table. So we see this stair step, and mine's not going to be drawn perfectly. My periodic table is not to scale and all that. But what we're actually going to see with our periodic table is that everything on the periodic table that is to the left of that staircase, with a couple exceptions, all of these elements are going to be metals. And I'm going to get close to the staircase, but not all the way to it. So all of these elements are metals. The other elements that are metals are actually the F block elements. So the F block elements that are at the very, very bottom of the periodic table are also going to be metals. So all of these are metals as well. That's a huge portion of our periodic table. The majority of elements are metals. So in terms of what that means or what that tells us is metals have some properties that are similar for all metals. The first thing is that they're good conductors of heat and electricity. That's why we use metals to make frying pans. We don't use oxygen. And we use wire for any kind of electrical work. So when you're plugging in your cell phone, those are little metal prongs that you're using. Most metals are solids at room temperature. And when we say most, it's actually all except for one. There's one element that's a liquid at room temperature, which is mercury. It's abbreviated as Hg. So mercury at room temperature is actually a liquid. It used to be used in thermometers, but all other metals are solids. They also have two other properties that really just mean that metals have flexibility. So the first one, they can be hammered or rolled into sheets. This is called being malleable, which really again just means flexible. So if you picture drinking soda out of a soda can, when you're done with the soda can, you can step on it and it crunches. And that soda can was made first off by taking metal and squishing it and rolling it into a sheet, but then it's flexible and you can step on it. Okay. Another vocab term is ductile, which means that metals can be stretched out into wires. And that's how they make electrical wires. By pulling on the metal, it doesn't just break. It can be rolled out and stretched. Okay. So this is true for all metals on the periodic table. The staircase is here. The elements to the right side of the staircase are nonmetals. Literally, our definition of nonmetal is not metals. That's what nonmetal means. Okay, so that's these elements over here, as well as hydrogen. So hydrogen is actually a nonmetal too, even though it's on the left side of the periodic table. So for nonmetals, we're going to have the opposite properties as metals. So if metals were good conductors of heat and electricity, nonmetals are poor conductors of heat and electricity. This is kind of good. Air is made out of a lot of nonmetals. When you're sitting next to an electrical outlet, if air was conductive, we would be getting electrocuted all the time. That would be bad. Most nonmetals, not all, are gases at room temperature. Examples are hydrogen, helium, oxygen, nitrogen. So lots of examples of gases at room temperature. They're not all. There's some that are solids, like carbon. When you're using your pencil lead is actually made out of carbon, not lead at all. There is a nonmetal that's a liquid, which is bromine. So not all nonmetals are gases, but the majority of them are. When they are in their solid form, for example, pencil lead, nonmetals are what is called brittle. And brittle just means that it's not very flexible. It's not malleable. And if you try to stretch or bend or fold your nonmetal, it's going to snap. So picture a piece of aluminum foil. You can bend it and fold it. If you picture your pencil lead and you try to bend it or fold it, it's going to snap. Okay. The elements that are right along this stair step, the staircase on here, are called metalloids. And our metalloids are these staircase ones. So let me write that on here. And they're kind of this dividing line. There's actually a good picture of this on the next page of the notes too. So if your picture is not great, that's okay. And I'm going to just draw this up. Aluminum is a metal too. So that's kind of one little piece of the staircase. So metalloids are in between metals and nonmetals on the periodic table, but also with their properties. So metalloids have characteristics of both metals and nonmetals. They're known as semi-metals sometimes. So in terms of some of their properties, they are less malleable. So that means they're less flexible than metals are, but they're less brittle than solid nonmetals. So not super flexible, but not super snappy the way that pencil lead is. In terms of their conductivity, they're not exactly good conductors, but they're not exactly poor conductors. We call them semiconductors, and that's really important in the computer business. Any kind of technology that uses computer parts and chips, a lot of that has semiconductors, and those are made out of metalloids. So your cell phone has them. And all of our metalloids are going to be solids at room temperature. And there's no exceptions to that. They're just all solids. On the next page of your notes, there's actually a picture of this where it's shaded. So all the ones that are this grayish color are metals. The metalloids on here are shaded a darker color. I'm just going to highlight them just so that it's clearer to see which ones those are. But if we have that staircase on here, the way that it is on our actual periodic table, you can see that what it is it's the elements that are right above and below that staircase, with the exception of aluminum. Aluminum is just a metal. But all the rest of them are like above and below that staircase. So those are some of the ways that we break the periodic table into some different chunks. The next page of notes, we're going to talk about how we classify elements within a specific family into some more specific properties as well.